solution. So today we'll discuss about multiplication of matrices. So yesterday we discussed about sum of matrices, difference of matrices. What will happen when you multiply a matrix with a scalar quantity, right? So all these things are there. Now see. Yeah, tell me.
Sir, the additive identity is a zero matrix or zero, sir?
Zero matrix. Good. So here they've given it, no, read it. If A is a matrix of order m cross n and 0 B of order m cross n, it's a zero matrix because you cannot add a matrix to a number. You can only add similar kind of items or subtract similar kind of items. Okay.
Okay, sir.
Yeah. So we saw all these kind of operations. Today we are going to see an important one, which is multiplication of matrices. Okay. So that is when two matrices of specific order are given to you. Then under what condition will you be able to multiply them is what the question is. Okay. So, but before that, let's try to consider an example. Suppose Meera and Nadeem are two friends, and Meera wants to buy 2 pens and 5 storybooks, while Nadeem wants to buy 8 pens and 10 storybooks. Okay, they both go to a shop to inquire about the rates, which are quoted as follow. Okay, when you talk about a pen, it is 5 rupees each, and when you talk about a storybook, it is rupees 50 each. Okay, so how much money is each supposed to spend? Right? How to proceed with that? So Meera wants to buy 2 pens, right? So 2 into 5 plus 5 into 50. So how much is this coming to? 250. So she has to spend 260 rupees. Similarly, what about Nadeem? So it will be 8 into 5 plus 10 into 50. So it is going to be 500 plus 40, which will be 540. Is that clear? But how to arrive at these numbers with the help of matrices? So here there is a statement that is given to us, and we have converted it into a linear combination, I can say. Right? So I've taken the number of pens that are needed, multiplied with the cost of each pen, plus number of storybooks multiplied with the cost of each storybook. But how will you be able to convert the same thing into, right? How will you be able to convert the same thing with the help of matrix? For that, what we can do is, we can put a matrix called as requirement matrix, where I will write 2, 5, 8, 10. What do they represent? So what do those numbers represent? So the first column represents the number of pens, and the second column represents the number of storybooks. Right? Next, what I will do is I'll create a column matrix. Okay, I'll create a column matrix where the numbers are written as 5 and 50. What do they represent? That is for the price per piece in rupees. Okay, now what I will do is 2, 5. Observe this clearly. Okay, 5 and 10. Okay, this I can, if I am able to represent it as, for me to get the 260 and 540, which is the cost that is to be spent by each person. So if I have to get a 260 here and a 540 here, then what kind of multiplication am I supposed to do? This 2 is multiplied with 5. Is that right? So 2 into 5, and you will add it to this 5 multiplied with this 10. Is that right? Similarly, you do 8 multiplied with 5 plus 10 multiplied with, oh, this 50, sorry. 10 multiplied with 50, which is going to give you 260 and which is going to give you 540. Is that clear? Okay. Is it clear? So if you need to do matrix multiplication, then the first point that you need to note here is, what is the order of the first matrix that you have? You have 2 cross 2 matrix, and the other one you have is 2 cross 1. In the sense, the column of the first matrix should be equal to the number of rows of the second matrix. Then you can start multiplying them. Then how will you multiply? Rows are multiplied with the values in the corresponding columns. Is that clear? So this is what is called as matrix multiplication. Okay. So let us see how the statement is written. So the above that we have considered is an example of multiplication of matrices. So we can observe that for multiplication of two matrices, the number of columns in A should be equal to the number of rows in B. Please make a note of this. For multiplication of two matrices A and B, the number of columns in A should be equal to the number of rows in B. Okay. Okay. Then how to perform the operation? For getting elements of the product matrix, what we do is we take rows of A and columns of B and then multiply them accordingly and take the sum of them. Okay. So from here we can say that the general way of representing the matrix multiplication is the product of two matrices A and B is defined if the number of columns of A is equal to the number of rows of B. Let the matrix A be Aij of order m cross n and B be a matrix of order Bkl of the order n cross p. So I made a mistake. What is it? So check and tell me what is the mistake I made. Yes, it should be Bjk. Why? Because the number of columns here should be equal to the number of rows in the matrix A. Okay. Then the product of the matrices A and B is the matrix C of order. Then what will be the output matrix order? So A into B, if I call it as C, then C will be a matrix. Okay. Then C will be a matrix which is equal to C I K, which is of the order M cross P. Okay. Which is of the order M cross P. That's it. Okay. Let us take an example and try to understand this. If I take C is equal to, if I take C is equal to 1 minus 1, 2, 0, 3, 4. What is the order of this matrix? 2 cross 3. If I take 2, 7, minus 1, 1, 5, minus 4, this is of the order 3 cross 2. Then what will be the output of the, what will be the order of the output matrix? Then what will be the order of CD? Then what will be the order of CD? Yeah, M cross P only. What did I write? So here it should be of the order 2 cross 2. right? But how to perform the operation? When you take CD, right? CD will be 2 cross 2, correct. So when you do the CD, let's say rows should be multiplied with columns and you need to take the sum of them. So 1 will be multiplied with 2. So 1 into 2 plus minus 1 will be multiplied with minus 1 plus 2 will be multiplied with 5. Okay, that will give you one element. Similarly, this 1 should be multiplied with 7. 1 into 7 plus minus 1 should be multiplied with 1 plus 2 should be multiplied with minus 4. Okay, next. 0 should be multiplied with 2. 0 into 2 plus 3 should be multiplied with minus 1 plus 4 should be multiplied with 5. Similarly, 0 should be multiplied with 7 plus 3 should be multiplied with 1 plus 4 should be multiplied with minus 4. So what will be the output? So this will be equal to 2 plus 1 plus 10. So it is 13. 7 minus 1, 6. 6 minus 8 is minus 2. Here I'm going to get minus 3 plus 20, that is plus 17. And here I'll get 3 minus 16, that is minus 13. So this will be the output matrix. So 3 minus 2, 17 minus 13. Is it clear? Okay. Now, you guys try this. 6923. Keep trying it. So you got the answer. So
Yes, sir.
AB should be equal to how much? 6 into 2 plus 9 into 7. 6 into 2 plus 9 into 7. Similarly, here you will have 6 into 6. So what will be the order? 2 cross 3 and this will be, 2 cross 2 and this will be 2 cross 3. So the output matrix will have the order of 2 cross 3. Correct? So I hope you got it. Right? So here, one important point to be noted is, if at all in a particular problem you are able to define AB, if there is a question like, is BA also possible? The answer completely depends on the number of rows and columns those particular matrices have. Because what is the important condition for matrix multiplication? It is always necessary that the number of columns of the first matrix should be equal to the number of rows of the second matrix. Okay, if they both are of different order, right, then there is a possibility that if AB exists, BA might not exist. Okay. Now, example 13. In a similar way, AB need not be equal to BA. Like how you do summation, right? A plus B is equal to B plus A, which is commutative law. It is not necessary that it happens for multiplication as well. So solve it. A is equal to 1 minus 2, 3, minus 4, 2, 5, and B is equal to 3, 4, 5, 2, 1. Find AB and BA. And we need to show that AB is not equal to BA. Do it fast. Don't look at the solution, you guys try it. So done. So you observe that AB is not equal to BA. So let's try example 14. So example 14 is 1, 0, 0, minus 1 and B is equal to 0, 1, 1, 0. Then prove that AB is equal to 0, 1, minus 1, 0 and BA is equal to 0, minus 1, 1, 0. So what is it? A is equal to 1, 0, 0, minus 1 and B is equal to 0, 1, 1, 0. Okay. Then find the value of AB. So AB will be equal to 1 plus 0 and 0 plus 0. It is going to be 1 plus 0. Here it will be 0 minus 1. It will be 0 plus 0. So answer will be 0, 1, minus 1, 0. Then what about BA? BA will be 0 into 1. That is 0 plus 0. Then you will have 1 plus 0. Then you have so for BA, I'll write B this side 0, 1, 1, 0. So 0 into 1 minus 1. Sorry. 0, 0. So 0 plus 0. Then you have 0 minus 1. Then you have 1 plus 0. Then you have 0 plus 0. So it should be 0 minus 1, 1, 0. So this is called as BA. Okay. Next is zero matrix as the product of two non-zero matrices. So if at all we take two real numbers for matter AB, and if they give you AB is equal to 0, then what can happen is either A will be 0 or B will be 0. But this is not true for matrices. We will observe through an example. Okay. See, for example, if you take A is equal to 0, minus 1 and 0, 2, and B is equal to 3, 5, 0, 0. Okay, then what is AB going to be equal to? Then what is AB going to be equal to? AB will be equal to 0 plus 0. It will actually be 0, 0, 0, 0. Right? So from this, what we can conclude is AB, the product of A and B is coming out to be a zero matrix. But here, if you observe, none of the matrices which are individually taken, that is either A or B, they both are not zero matrices. So matrix does not have something similar to that of a real number is what we are trying to say. Then the properties of multiplication of matrices. Okay. So the following are the properties which matrix multiplication possesses. First one is called as associative law. So if you have AB multiplied, so you first multiply AB, then multiply it with C. It is the same as multiplying BC, multiplying A with the product of B and C. Okay. Second is distributive law. So if at all there are three matrices A, B, and C where the feasibility of multiplication is possible, then you can say A into B plus C is equal to AB plus AC. Similarly, A plus B into C is equal to AC plus BC. Okay. The third one is existence of multiplicative identity. This is a very, very important one. So this will give us the lead for inverse of a matrix. Okay, listen to this. For every square matrix A, so the existence of multiplicative identity is applicable only for a square matrix. So yesterday, if I take a number 5, then what is the multiplicative inverse of 5? Or multiplicative identity? Let me rephrase my question. What is the multiplicative identity of 5? No. You're talking about inverse.
1.
It is 1. So 5 into 1 is 5. I told you yesterday there are two things, identity and inverse. So identity means if I call it as additive identity, means to that number I need to add a particular number so that the output is the same number. For example, the additive identity of 5 is 0, because if I add 0, then the output will come out as 5. Whereas if I say multiplicative identity, it is 1. Okay. So here multiplicative, so this is for a real number, but here we are dealing with matrices. Okay. So first thing that you need to note is there is something called as identity matrix, which I would have explained it in the beginning of this chapter. So identity matrix are square matrices. Okay. For every square matrix A, there exists an identity matrix of the same order such that the product of identity matrix and A is the same as A into I is same as A. So this property is very, very, very important. If you understand this only, you will be able to calculate the inverse of a given function. Okay. So find out these values. Now they are asking us to verify the properties. So A is a matrix of order 3 cross 3, and B is a matrix of order 3 cross 2, and C is a matrix of order 2 cross 4. Then find out A into BC, then find out AB into C, and show that they both are the same. So this is what is the associative property, right? Here, with the help of an example, we are trying to prove the associative property. Do it fast. Are you done? So are you guys getting this AB into C is equal to A into BC? Hmm? Guys, you want me to do or you're able to do? At least message me, no? Okay. So only one guy is responding. What about others? Hmm. Good. Do it, do it. Yeah. So they are able to prove that AB into C is equal to A into BC. So let's do example number 17 now. A is equal to 067 minus 608 minus 7 minus 08 and B is equal to 0, 1, 1, 1, 0, 2, and 1, 2, 0. C is 2, minus 2, and 3. Okay. So calculate AC, BC, and A plus B into C. So what is AC? So this is 3 cross 3. This is 3 cross 1. So you should get a 3 cross 1 matrix. So 0, minus 12, plus 21. So you'll get 9 here, minus 12, plus 0, plus 24. Should get a 12 here. 14 plus 16. 14 plus 16. 30. So you should get a 30 here. So 9, 12, 30. Then what about BC? Zero, minus 2, plus 3. 1, 2, plus 0, plus 6. 8, 2, minus 4 is 2, minus 2. So minus 2. So 1, 8, minus 2. Then we'll calculate A plus B into C. So what is A plus B? 0, 7, 8, minus 5, 0, 10, 8, minus 6, 0. So this multiplied with 2, minus 2, and 3. How much is it going to be? Minus 14 plus 24. It is 10. Minus 10 plus 30. It is 20. 16 plus 12. 28. So 10, 20, 28. So what is AC plus BC? AC plus BC is going to be 9 plus 1, 10, 12 plus 8 is 20, 30 minus 2 is 28. So AC plus BC is the same as A plus B multiplied with C. Right? Now, listen. This one alone, I'll do and show. So this is an important problem. Mark it as important. So A is equal to, we have 1, 2, 3, 3 minus 2 and 1, 4, 2, 1. Then we need to prove that A cube minus 23A minus 40 into I, where I is the identity matrix, is equal to 0 matrix. Okay. So don't treat them like a cubic equation. Don't do that. So for that, what we will do is, before we find out A cube, first we need to know what is A square. So A square is A into A. So how much is A into A going to give us? 19, 4, 8, right? So let us do it actually. So 1 plus 1, 1 into 1 plus 2 into 3 is 6, 7. 7 plus 12 is 19. So I think you will get the same. 19, 4, 8, 1, 12, 8, and 14, 6, 15. Okay. Then what is going to be A cube? A cube will be written as A square into A. So A square into A is going to give you 63, 46, 69. 69 minus 6, 23. 92, 46, and 63. Okay. Now what we can do is, you find out A cube minus 23A. So A cube is this thing. What is 23 times A? So this is scalar multiplication of a matrix, means every element of matrix A should be multiplied with 23. So what will happen? It will be 23, 46 and 69. 69 minus 46 and 23. 23 fours is 12. 92. 92 again 46 and 23. Okay. And 40 times I. So what is I basically? 100, 010, 001. Correct? So when I say 40 times I, it is going to be 40, 00, 040, and 0040. Okay. So take it and substitute, then you will get the expression like this. So once this value comes out, you try to add all the values, then you will get 000, 000, and 000, which is a zero matrix. Okay. See, I think other problems you can do it. This chapter is almost over. So there is only one concept that I need to explain, that is the existence of inverse, and then I can start off determinants. Okay. See, none of you are responding. It is really boring for me to even sit and solve. It is as if I am solving for myself. Okay. You guys better do it as homework and come for tomorrow's class. We'll wind up the session. See you all. See, if you guys are going to respond, I will teach. Transpose is there. Symmetric, skew symmetric is there. Okay. So that I'll explain tomorrow. You first solve these problems. I was expecting some kind of response. I'm taking class for the past 2 hours and the class is like this only. It is as if I'm talking to myself. Okay, my interest is gone. So I'll take tomorrow.